Alright, good morning. I'm going to go over the chapter 2 to 4 practice end of term test quickly so that you can get some understandings for the questions you don't get. So the first section is calculator not permitted, so let's see if we do these questions. Determine the least common multiple of 48, 72, and 108. So when I see here, we can't use our calculator. Normally you just write a list of each one, 48, 72, and 108. And you'd write a list of each and see which one they all get in common. You want to write lists of multiples of each. So you'd go 48, 96 next until you get the smallest number that all matches. But that you would kind of need a calculator for. You probably could. You might be able to do it in your head, but here's another way to do it. So 48, you can prime factor into... you can prime factor all these down. We know how to do that. I'm just going to write the prime factored version of each one. 2 times 2 times 2 times 3. This one ends up being 2 times 2 times 2 times 3 times 3. And then this one ends up being 2 times 2 times 3 times 3 times 3. Okay, so you have those three prime factored versions of these three numbers. And how you find the least common multiple, not the greatest common factor. Greatest common factor, you just choose the least number of each one, so 2 2s and 1 3. But the lowest common factor, you actually end up end up finding the highest number of each numbers. So how many 2s are there here? There's 4, there's 3, and there's 2. So you take the highest number, 4 of them. So 2 times 2 times 2 times 2. And then the next one here, you take the highest number of 3s. Let's see, there's 1, there's 2, there's 3. So we'll take the 3 from there. 3 times 3 times 3. And so that's our lowest common multiple. So it ends up being that one there. We're not even sure what number it is, but we know it's that. Okay. It turns out it ends up being 432 is the lowest common multiple. Okay, it's the number that all three of these numbers divide evenly into. Okay, the next one. Just identify the greatest common factor of this huge thing. 6s cubed t fourth plus 12s fourth t squared minus 15s squared t cubed. Okay, so here, when I look at this, let's rewrite it very quickly. Plus 12s fourth t squared minus 15s squared t cubed. I have to take the greatest common factor in the coefficient, which ends up being a 3. Now I look at the s's. What's the biggest degree one? There's a 2, 3, and a 4, so we'll take the 2. And then the t's. There's 4, 2, and 3, so we can take a t2 out. So that'll leave us with 3 times what gives us 6, 2, and then 1s left over, because 3 minus 2 is 1, and then left over 4 minus 2 gives us t squared. Okay, that represents this one. Now we go into the next one. And then I'm going to stop there. We could keep going, but they just want the greatest common factor, which is this one. So 3s squared t squared gives us b. Okay, so we have a and we have b. Alright, now we go to the next one. Which of the following statements are true? All whole number factors of 20 are these. Yeah, they all divide evenly. That's right. The prime factors of 20 are 2 and 5. Yeah, those are the only ones out of these that are prime. One doesn't count as a prime, so that works. The prime factorization of 20 is 2 squared times 5. Yep, those are all prime numbers, and they're what multiplies to that. It's actually the only thing that's prime and will multiply to that. Root 20 is irrational. If I typed it in, I get this non-repeating number, so it's irrational. Okay, so D for that one. Alright, so now we're going on to the next one. Chris completes one lap of a go-kart track every 30 seconds. Darcy completes one lap of the track every 40 seconds. Suppose they cross the starting line at the same time. How many laps will they have completed to do that? Okay, so this, it's kind of hard to know this, but let's see. I would say 30 seconds. The first person, let's see, Chris, and then Darcy, 30 seconds to complete. Darcy took 40 seconds. And then 60 seconds to complete his second lap, 80 seconds to complete his second lap. And then you keep going, 90, 120, 120, and then I look and I see those two are the same. So at 120 seconds for them both, completed the fourth lap, completed the third lap. Okay, so how many laps will Chris have done when completing when they cross at the same time? So 1, 2, 3, 4 laps. Okay, so this actually is a lowest common multiple question, but you can kind of reason through it. All right, which of the following? Oh, I circled the wrong one. 1, 2, 3, 4 laps. It's B, not C. All right, which of the following number sets contain only irrational numbers? When I look at this, that's rational because it's in a fraction. I know that that's 3. This is repeating, so that can be formed into a fraction, so it must be D. Which of the following statements are true? Cube root of 8 is equal to, since 2 times 2 times 2 is 8. That's true. Square root of 6 is equal to 3. I know that's not true, so it's not true. That one's true. This one is true, because we can bring the 4 cubed in, and it'll be 64 over 27. And then this one, the fourth root of 16 is equal to 4, since 4 plus 4 plus 4 plus 4 is 16. No, it should be 4 times 4 times 4 times 4. So not that one. So 1 and 3. This one's C. Now we have this, right? Cube root of 1372 in simplest form. Well, we got to do prime factored to simplify that. So we have a 2, 686, 2, 343, 7, 49, and a 7 and a 7 there. So overall this can be represented as the cube root of not 1372, but cube root of 2 times 2 times 7 times 7 times 7. We have to do groups of 3, so we have to take those 3 and bring it out. So that's going to be 7 cube root of 2 times 2, which is 7 cube root of 4. D. Alright. What are these numbers from greatest to least? So when I see this example here, without using a calculator, you'd have to simplify each of these so that they're all under just a radical. They're not a mixed radical. So this one here, you have to bring the 2 on the inside. So you bring 1 2 to 2 2's. So it's going to be 4 times 30. So this one's root 120. And you got to do that same with each one. 3 turns into 2 3, so it's going to be 3 times 3 times 3, which is 27. This one here is going to be 2 times 2 times 7, so 28. This one's going to convert, you bring the 5 inside, so it's going to be 5 times 5 times 5, 125. Because 1 5 turns into 2 5s, and there's already a 5 in there, so there's 3 5s. 2 times 2 times 13 for the next one, which will give me 2 times 2 times 13 gives me root 52. So now you got to order them from greatest to least. So the greatest one's going to be the highest number. So there's 1. It's going to start with 5 root 5, so it's already not those two. And then the next one is going to be this one, 2 root 30. Yeah. Next one's going to be that one, 2 root 13. It's got to be B. Alright, evaluate 64 to the negative 4/3. So when I see this, I see a negative symbol, so I'm going to put it 1 over, and to the positive 4 over 3. Okay, and then I know I can take a cube root of 64. What times what times what gives me 64? 1 over 4 to the power 4, because 4 times 4 times 4 gives us 64. And then you got to ask yourself, what's 4 to the power 4? 4 to the power 4 has to be 256, because that's all you see here. So it's going to be 1 over 256. A. Okay, this one use exponent laws to simplify. We're going to have x to the 1 over 8, because that's what that means, times x to the 3 over 5. Okay, same base, we can add the 2. So we can go 1 over 8 plus 3 over 5. which is kind of a difficult one to do. So you have to have the same bottoms to add them together, so we got to make them the same. So times by 5 times by 5 times by 8 times by 8, and this will be 5 over 40, and then this one's going to be 24 over 40. So now, since the bottoms are the same, we can add the tops, which will give us 29 over 40. So overall, this gets brought down to the same base, and when you add those two together, you get 29 over 40. Okay, which is the same as this one. C. Alright, 11, last one without a calculator. What is the difference between angle of depression and angle of inclination? Draw a diagram to support your answer. So if you have some horizontal line, horizontal means kind of the same direction as the top of your page. If you go up from that, that angle is elevation or inclination. And then if you went down from that dotted line, that would be the depression. Alright, on to the calculator section. So here we have to expand and simplify 5m minus 3n squared. That's the same as just writing it twice. We got to FOIL this out. That times that, that times that. So we get 25m squared minus 15m n minus 15mn, because that has to times by that, and then that by that, plus 9n squared. So we get 25m squared minus 30mn, because we can add those together, because they're like terms, and we get that. C. Okay, this one we have to use a box method. They said we haven't really seen this, or we have seen it, but we haven't used it too much, using the area model. So 4s plus 9t, and then here 5s minus 4t minus 3. So kind of like that they want to do it. So you go this times this, 20s squared, 5s times 9t is 45st, and then negative 4t times that, negative 16st, negative 4 times 9 is 36 negative t squared, and then negative 3 times 4 is negative 12s, negative 3 times 9 is negative 27 t. Alright, so overall these are all kind of their own thing. We can add those two boxes together though, because they're both STs. Okay, so if you add those together, you would get 29st. Okay, so that would kind of take place of those two. So we have 20s squared 29 plus 29st, negative 36t squared, negative 12s, negative 12, negative 27t. Okay, so negative 27t, it can't be this one then, because that one's positive. The next one we have negative 36t squared, so it can't be b because that one's positive. Now we have negative 12s. Yeah, still can be a or d. 29st is positive. Yeah, can't be this because it's not 61, so it's got to be a. Alright. On to the next one, expand and simplify this. Well, this one's a long one. When I see this, I don't like to do these ones, but here we go. 18x squared plus 48xy, because we go this times that, negative 3xy, and negative 8y squared. And then this one's tricky. It has a negative sign out the front of this, which is a binomial squared. So you'd have to write this out twice. I'm not going to distribute this negative sign in yet. I'm going to do this squared. I'm going to deal with that first. So that means I need to write my answer in brackets, because I got to remember to do that negative distribution at the end. So I'm going to do a negative sign and then put a bracket. That's very important. So now we go. This really gets broken to 2x minus 3y times 2x minus 3y. And we go 2x times that, 2x times that, negative 3y times that, negative 3y times that. So we get 4x squared, negative 6xy, negative 6xy, and then plus 9y squared. And I finish it off with a bracket to show that I still have to bring this negative sign on the inside, okay, to each of those four. So now let's rewrite everything. 18x squared plus 48xy, negative 3xy, negative 8y squared. Bring the negative sign to everything, so negative 4x squared plus 6xy plus 6xy, and then negative 9y squared. Alright, so now there's no more brackets, no more distributing to do. So now we just have to add like terms. So we got an xy, any more x squared, so we got 18x squared, and we have a negative 4x squared. So let's add those together. We get 14x squared. Now we have an xy, 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 xy. So a lot. 48 minus 3, 45. Plus 6, 51. Plus 6, 57. xy. And now negative 8 plus negative 9, negative 17 y squared. It's got to be D. Gross question. All right, which of the following has a factor of x to the negative 3? Okay, so what you have to do is you have to kind of factor each of these to kind of see that. 2x squared plus 18, we can take a GCF out, we get an x squared plus 9. That doesn't factor any further. It's not a difference of squares because it doesn't have a negative sign there. So that one's a no. This one here looks like a trinomial, 1, 2, 3. It's an easy trinomial because there's nothing there. So we have to find out what multiplies to 12 that adds to negative 7. And that's going to be negative 4 and negative 3. Negative 4 times negative 3 is plus 12. Negative 4 plus negative 3 is negative 7. So that means my answer is going to be x minus 4, x minus 3. The only reason I can do it so quickly is because it's an easy trinomial. There's no coefficient in front of the first one. So it's saying, is x minus 3 a factor? X minus 3 a factor of this? It is. Now I have to do this one. This one's a tough one. 2x squared minus 5x minus 3. So I got to go 2 times 3, which gives me negative 6. Okay, so what adds to negative 6? That what multiplies to negative 6 that adds to negative 5? Well, that's going to be a negative 6 and a positive 1. Okay, so now I rewrite this. 2x squared. Instead of the negative 5, I'm going to write negative 6 plus 1. Negative 6x plus 1x. And then I write the negative 3 again. I don't write the negative 6, I write the negative 3. Okay, now we have to factor this right here. Well, 2 and x can go into that, and that'll leave us with an x minus 3. And then this, nothing, so I'm going to put a 1, and that'll leave us with an x minus 3 as well. Okay, so now I write the inside bracket, x minus 3, and then I'll write what's left over, 2x plus 1. Is x minus 3 a factor? It is. So 2 and 3. D. When completely factored, how many factors does x to the 4th plus x squared minus 20 have? Let's try to factor it. What multiplies to negative 20 that adds to 1? Well, that'll be positive 5 and negative 4. So this will be, since there's no coefficient in front of there, we can do the easy way. X plus 5, x minus 4. The only thing I didn't remember is that it's x to the power 4, not to our x to the power squared. So we gotta square our x's there. Okay, can I do anything else? This one here is a square number, and a negative sign. So that means I can do difference of squares. This one's not. So we can go x, the square root of 4 is 2, so plus 2, x, negative 2. So how many factors does this have? 1, 2, 3. Kind of 3 brackets, so 3. Number 17. How many integer values are there for k for which this is factorable? So I'm going to ask myself, what multiplies to 3 times negative 12, negative 36? So when I see this, what adds to negative 36? So it's going to be we got 9 and 4, 12 and 3, 36 and 1. Anything else that goes into there? 18 and 2. So we have 1, 2, 3, 4, 6 and 6. 7 no, 8 no, and then 9 so that seems to be all the factors that can go into this negative 36. Okay, all the factors that can go into that. So now we can go we can have one negative, or both positive, or any of those versions. So here we can go 6 plus 6, 6 minus 6, and those are the options. Here we can go 36 minus 1, 1 minus 36. So there's lots of different versions, but I guess if we want to go to negative 36, one of them has to be negative. Okay, so I have to do either that one or that one, 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 that one or that one. So if we have negative 9 and positive 4, that'll give us negative 5. If I have negative 4 and positive 9, that'll give me positive 5. If I do negative 12 and positive 3, that'll give us negative 9 or positive 9. This here will give us negative 35 or positive 35. This one will give us negative 16 or positive 16. This will give us 0 or 0. So how many integer values? 1, 2, 3, 4, 5, 6, 7, 8, 9, because that's counted twice. 9 integers would make that factorable. Alright. Now this next one here, let's write it a little bit bigger. Negative 15y to the 12 over negative 64x cubed all to the negative 1/3. So I have to distribute this negative 1/3 to all 4 of those. So negative 1/3 times negative 15 gives us 15 over 3. Y to the negative 12 over 3. Negative 64 to the negative 1/3. And x to the negative 3 over 3. Now that gives us w to the 5, y to the negative 4, x to the negative 1 over 1 is just x to the negative 1. This one's it's a negative symbol, but we need to take the cube root of 64, or of negative 64. So what times what times what gives us negative 64? I know that's going to be negative 4, but it's still to the negative sign. So it's going to be negative 4 to the negative 1. And this is going to give us, we got to swap all the negative signs to their other sides. So it's going to be W5. This is going to go up, x to the 1. And then also that 4 is going to go up, so it's going to be negative 4. And then this y goes down, y to the 4th. So I'll end up with a negative 4 W5 x1 all over y to the 4th. So that's a D. Alright, at a point 25 feet from the base of a totem pole, 25 feet from the base, the angle of elevation to the top of the pole is 50.1 degrees. How tall is the totem pole to the nearest foot? So this is just a trig question. So we have O and A, so it's going to be tan of 50.1 is equal to x over 25. Okay, solve for x and we get x is 25 tan 50.1. So there our x is going to be 25 tan 50.1, 29.9. So it has to be that C, 30. 20. Calculate the measure of angle ABC to the nearest tenth of a degree. So angle ABC means from, if you draw a line from A, B to C, it's the middle one. So it's from here to there. Okay. So one way I can see is that I need to find out what this little angle here is, and I only have one piece of information there. So I need to find another piece of information, and I know I can find this from this bigger triangle. Okay, so let's find out what this side length is, because then when we do that we can solve this little angle and this little angle. Okay, so this one here I can find by Pythagoras. We have the right triangle there, go across. This is the H, or the C in Pythagoras. So it's C squared is A squared plus B squared. Our C squared is 13 squared. Our A squared will make the side that we're trying to find. And our B is the 7 from here to here. So 7 squared. Okay, so 13 squared is 169. A squared plus 49 minus this 49 over. And we take the square root. So our A is going to end up being 10.95. That's what this is from here to here. So this is 10.95. Alright, so now I can find the angle from here to here, which I'm going to do using sine, because I have O and I have H. So sine theta is O, which is 7, over H, which is 13. Okay, and then we have to solve for theta, so we have to do the opposite of sine, which is sine inverse of that. Let's find out what that is by typing it in. And we get 32.6 degrees from here to here. Okay, now let's find out what here to here is. So we have 4 and we have 10.95, so we have O over A. So it's going to be tan theta is O, which is 4, over A, which is 10.95. And here, adjacent. Find the opposite of tan, which is tan inverse of that. Over 10.95, and we end up with 20.1 degrees. So we have this plus this will give us our whole angle, so it's going to end up being 52.7, or 52.6 is close enough. There we go. Alright, a student stood 8 meters from the base of a tree. She used a clinometer to sight the top of the tree. So here's our tree. Clinometer is like an angle thing, kind of what I had, to be 25 degrees here. The student held the clinometer 1.6 meters above the ground. 1.6 meters above the ground here. Determine the height of the tree. I guess the tree is that high as well. To the nearest tenth of a meter. So if you look at this, we're going to have to find out what from here to here using this triangle is. So from there to there we can use, let's see, O, and this is A, so we're going to have to use tan of 25 degrees is O over A, O over A, which is 8. We don't know what O is, so let's solve for it. Times it to the other side, 8, 10, 25, and our O is going to be 3.7 meters, is from here to here, and then we also have to add how tall the person is, 1.6 meters here as well. So 3.7 plus 1.6 is 5.3. B. Alright, last page. The length of the body diagonal in this rectangular prism is 61 centimeters. So from A to F is 61 centimeters, that dotted line. The width of the prism is 29 centimeters. That's from here to here, A to D. The measure of angle AFH, AFH, right, they indicated it, is 23 degrees there. Determine the length of the rectangular prism to the nearest centimeter. So if this is the width, the length is kind of like the A to B section, or also the D to C, or the E to the F, or the H to G. One of those lengths is what you have to find. Okay. So one thing you know about rectangles or squares, that's a right angle down there. Okay. It doesn't really look like a right angle the way they draw it, but that's a right angle. Every kind of side with every other side is going to be a right angle because it's a rectangular prism, or a square prism would work as well. So I know using the 61 and this 29, can I do anything there? Not quite. But I have this 23 degree here. So I have one piece of information for this dotted line triangle, and I have the dotted line side there. So I know with that I can either find another angle, another side length, or that side length there. Because I have two pieces of information, I can always find a third. So what piece would help me out of those three pieces of information? If I want to find this side length, then I know, let's see, if this is 29, then E to H is also 29. So that means if I find out this piece right here, this dotted line, I think that'll give me two pieces of information on this triangle, which might help me to find this here. So let's find out what F to H is, okay, using this. So let's draw it kind of separately. This is the dotted triangle that I'm drawing. That's weird. That's 61 centimeters, and then in there was 23. So let's find out what this part was here. So I have O, H, and A. So I want to find out what A is, and I have H. So let's use cos. Cos of 23 is A over H, which is 61. So solve for A, and we get 61 cos 23. And we get 56.2 as our length here. 56.2, 56.2 centimeters. So that's what this is, 56.2. So now I have a right triangle with one side length, two side lengths, so now we have to find this last one. Okay, so now I've essentially made a triangle that goes like this, 56.2, 29, and I got to find out what x is. And that's when you use Pythagoras. C squared is a squared plus b squared. Our c is always across from the hypotenuse, which is 56.2 squared. A squared, here we can make x squared, and then b is 29. So now I minus this 29 squared over, so it's 50 squared minus 29 squared, and we end up getting 2,311.9 is x squared. Take the square root of both sides, and we get x equals 48 centimeters. Does that make sense? Yeah, if that's a side length 29, 48's reasonably close to that, so that makes sense. That's a tough problem. 23, calculate the nearest angle of GHJ, so that's this angle from here to here, to the nearest tenth of a degree. So when I see this, I need to know two pieces of information of the big triangle to be able to solve it. Okay, so I have this piece, which is nice, and then I also have to find this whole length here. So I have part of it from here to here, but I need to now know from there to there. So how you do that? Let's see. We can use Pythagoras with the smaller triangle, because we have two side lengths, we can find the third one. So we can go c squared is a squared plus b squared. Our c is 9. Our a we can say is 6. And let's find out what that b is. Okay, so that's 81, 36 plus b squared, minus the 36 onto the other side, and we get 45 is b squared. Take the square root, and we get b equals square root of 45, which is 6.71 roughly centimeters. So that means this is 6.71, which means for our big triangle, let's redraw it. Just the big triangle this time. G, J, H. We have 6.71 plus 4, which is 11.71. We have 6 centimeters, which is here. We find the angle, so we have an opposite and an adjacent, so we can go tan theta is O, which is 11.71, over A, which is 6. Take the inverse, and that equals 62.9 degrees. Which is not any of the answers. No, that's the problem. I didn't add right. It's not 11.71. 6.71 plus 4 is 10.71. That's my mistake right here. 10.71, 10.71, 10.71. And that means I just have to redo this calculation. This is 60.7. There we go. C. Thank you.